lesson will be about solving 3x3 system of equations. What that means is we have three unknowns, typically x, y, and z, and we have three equations, 1, 2, 3, where we know all of the other variables like c and b. And so we have three equations and three unknowns. That's usually the way it goes. If you have n number of unknowns, you need n equations to solve for those unknowns. So you will see this pretty much everywhere. This is very helpful. You will always be solving systems of equations, and so the best way to see it is by example. So here's our example problem. So in this case, our unknowns are a, b, and c. And we have three equations to solve for those. So our first step will be, let's solve for a from our first equation. And let's number these equations. It's 1, 2, and 3. So solving for a from the first equation gives us a fourth equation. Okay, now we have a. We want to substitute a into equations 2 and 3. All right, so I've plugged in a and created equations 4, 5, and 6. So that's these two equations here. Of course, I skipped some steps in factoring things through, but we now have these two equations in terms of just b and c. Now what we could do is solve for b from this equation in terms of c and plug it into this equation, and then we'd have one equation with just c in it, and we could find c. However, we might end up with some fractions that get a little tricky to deal with. So what we notice is that this term is negative 2b. And in our other equation, we have negative 6b. So if we want to eliminate b, we can easily multiply this equation by negative 3 and add it to this equation. So let's see what that looks like. So this equation times negative 3 becomes and if I now add this equation to that, we'll see that this 6b factor will cancel out of each one. And moreover, when I add this together, 9c minus 8c is just 1c, 15 minus 17 is negative 2. So that's our answer for c. And now we do what is called back substitution. We take c and go back to one of these equations. Either one will work. We can use either one, plug in c, and solve for b. So let's choose this equation here. So again, I skipped a few steps, but we plugged in c into this equation, solved for b, and got 11 halves. And now we have both b and c, and we can go back to equation number 4 here and solve for a by plugging in 11 halves for b and negative 2 for c. And again, I will skip some steps, but we will see that a ends up being negative 3 halves.